Hello, pre-calculus. Here we go. Section 7-4 of our notes. What's going to be a little bit different from what we just did is now we're going to take translations of the sine and cosine graphs, which means shifting them, up and down and left and right is what it's going to be all about. Here's a review question. This is straight from what we did the other day. This is 1/2 times x. That'll help us find the period. 3 is going to change the amplitude. My amplitude is 3. The b value is 1/2. How do you find the period? You got to take 2 pi and divide it by the b value. So 2 pi divided by 1/2 is going to come out to equal 4 pi. It should ask you what are the intervals. You should take 4 pi divided by 4, and each interval is a length of just 1 pi. So it's going to start at 0. Then it's going to be pi, 2 pi, 3 pi, and 4 pi. It's going to reach a height of 3 maximum and negative 3 minimum. And since the sine graph starts at 0, 0, at pi we're going to hit 3, 2 pi we're going to hit 0, 3 pi we're down here and here. And there's our sine wave. That's what our sine wave looks like. Might be some simple sine wave questions. Maybe about that difficult. Maybe some simple sine wave questions on your SAT, which is coming up next month, juniors, next month. All right. So you're going to perform translations of the sine and cosine. When I say translations, we're talking about going up, down, left, and right. You basically take a graph like we just did up above and shift all the points 3 units to the right, or 3 units to the left, or 4 units up, or 4 units down. It's the same kind of work we were doing before, but now we don't get the nicety of, hey, we start at 0, and then whatever you get for the period length, that's where it ends. There you got 0, you got 4 pi, find the points in between. It's going to be a little bit tougher to find the starting point and stuff like that. So that's what this lesson is going to be all about. It follows the same rules that we did when we shifted parabolas. Like if I gave you y equals x squared, you knew it was a parabola that looked like this. How can you make it shift? Well, how can you make it shift left and right? You added with the x. Like if I did x minus 2 quantity squared, that would shift it 2 to the right. And then if I wanted to go up, I can go up 5. This would go 2 to the right and then up 5, 2 to the right and up 5. So we've done this kind of work before. It's just now it's going to be with trig functions. All right, so keep in mind, my amplitude is 1. My multiplier in front of x is also a 1. It's going to shift. Adding pi over 6 inside the parentheses, shift your graph in what direction? So you have to think of it as like same thing that we did up here. You would sort of solve for the parentheses, set it equal to 0. You would have to subtract x equals negative pi over 6. It moves negative pi over 6 to get started. So it goes pi over 6 to the left. And that's where it's going to start, is at negative pi over 6. So from 0, 0, it moves over negative pi over 6. What is my amplitude? My amplitude is 1. My amplitude is 1. What is my period length? So my period length, because it's a 1 in front here, is just going to be 2 pi is the period length, 2 pi. You can always determine the starting point of your graph. So let's put a star. This should be highlighted a little bit more. This is new. You can always determine the starting point of your graph by setting what's in the parentheses equal to 0. Oh, I guess I already did that one. So x plus pi over 6 equals 0. So x equals negative pi over 6. So we already did that. Then you can always determine the distance between the x values by taking the period and divide. I think they're doing dividing by 4. So in this case, it's 2 pi and divided by 4 to figure out what the intervals are. Intervals. So each interval is going to be a length. All right, it's going to be a length of 2 pi divided by 4. That would give me pi over 2. So to write these other key points, it no longer just ends at the end of the period. It's not going to end at 2 pi. Everything shifted over. So it starts at negative pi over 6, and you're going to add 2 pi, or not 2 pi, you're going to add pi over 2. We need a common denominator. That's where, you got to be a little bit comfortable with fractions here. We need a common denominator between 6 and 2. The common denominator is 6, so I'm going to call this 3 pi over 6. Negative pi, 3 pi gives me 2 pi over 6, but we got to reduce that. So, actually, I'm doing the scratch work down below, but they wanted it up above. So negative pi over 6 plus pi over 2. We added 3 pi over 6. Sorry about that. And that's going to equal the next important point, which is going to be pi over 3, and that goes here. That's what they're demonstrating. Sorry, I didn't follow what they wanted for their scratch work. You're going to take this and you're going to add the interval to it. So we added pi over 2. Now we're going to add another pi over 2. Pi over 2 with a common denominator, we want it to be 6. So it's going to be 2 pi over 6 plus 3 pi over 6. 3 pi over 6 is pi over 2. 2 pi over 6 is pi over 3. Get a common denominator, add them together. They're going to equal 5 pi over 6. Now we're going to add another interval length. We're going to add pi over 2 again. The common denominator needs to be a 6. So I'm going to make this 3 pi over 6. Add those together. I get 8 pi over 6. I feel like they didn't do enough room here. But 8 pi over 6 becomes 4 pi over 3. 4 pi over 3. So we're at negative pi over 6. We're at pi over 3. We're at 5 pi over 6. We're then at 4 pi over 3. You know what? It's like they ran out of room here. You need the ending point here. What? They ran out of room. And then you're going to add one more. We're going to add another pi over 2. So I need a denominator of 6. Here, I'll do it here. 4 pi over 3. I need to add pi over 2. Let's make a denominator of 6. So double the bottom, double the top. 8 pi over 6, and we're going to call this times 3. 3 pi. 8 and 3 is 11. 11 pi over 6. 11 pi over 6. It is a sine graph, and the amplitude is only 1. It wasn't flipped upside down. It's going to start here. The y-axis is not an important point here. The important points are here, here. They call them critical points. And it's going to go up to 1 here, back to 0 here, down to negative 1 here, back to 0 here. And there is my sine wave. One period length, the main period length. One cycle of it. A lot trickier than what we did when it started at 0. Is a lot easier. But now, not starting at 0 makes it a lot tougher. All right, you got to think about it a little bit. All right, next one. They're going to change it to cosine. We know the cosine graph kind of looks like one of these. All right, that's what a cosine graph looks like. It's not flipped upside down or anything like that. What is the amplitude? The amplitude is 1. What is the period length? You take the normal period length of 2 pi and you divide it by whatever is being multiplied in front of x. So 2 pi divided by 2 is just plain old pi. Pi is going to be the period length. What's the distance between key x values? We've been calling that intervals. All right, intervals. How long are the intervals in between? You take pi divided by 4. And it's just going to be pi over 4. So we keep adding pi over 4 from wherever we start. The starting point, take what's in parentheses only and set that equal to 0. So I'm going to add pi and divide by 2. So x would equal, add pi divided by 2, x would equal pi over 2. So it actually, because of that minus sign, it actually shifted to the right instead of shifting to the left. Instead of starting on the y-axis, it's going to move over to pi over 2. That's where it's going to start. The amplitude is still 1, and so cosine starts where the amplitude maximum is. It's going to start here. Now, the trick is, what are these numbers? That's what you're really going to be graded on. Oh, and the shape of the curve, but that's what you're really going to be graded on, is can you figure those out? Each length is pi over 4. So you have to take pi over 2, and we got to add pi over 4. Common denominator is 4. So I'm going to get 4. 2 pi plus pi is going to be 3 pi over 4. Well, it's only going by quarters. I get it. That's half of pi. That's 3/4 of pi. So if I take 3 pi over 4, so you don't really need the scratch work if you follow fractions. And I add pi over 4, that's 4 pi over 4, but that's 1 pi. Now the next one's going to be 1 1/4. So it's going to be pi plus pi over 4. So call this 4 pi over 4. Now this one's 5 pi over 4. Right? And the next one's going to be if I add 5 pi over 4 and I add pi over 4, 6 pi over 4 becomes 3 pi over 2. Those are my key values, my critical points. Follows the normal sine curve, so I didn't get too crazy with amplitude or anything like that. So it starts at the top. The next critical point is going to hit 0. The next critical point is going to hit the minimum. The next critical point is going to be back to 0. And then at 3 pi over 2 is the ending. So it has this kind of a shape to it. You drew like a little arrow that it keeps going, but it's going to be here. It bottoms out, and it should look like a curve, and then it looks like it's topping out and coming back down after that. That's your cosine graph. So really what's difficult about the lesson today is if it shifts it left and right. Now I think, without even looking ahead, I think on the next page they're going to shift them up and down, and just like this over here, if they add or subtract a number, you have to sort of pretend the x-axis, we'll call it a midline going through the middle, that it'll either raise up or come down. All right, and that'll be the next step on the notes on the next page. We'll get to that in part 2.